The National Electrical Code, or NEC, has specific regulations regarding lighting fixtures in showers and bathtubs. According to NEC Section 410.10, C. Lighting fixtures shall not be installed directly above or within showers or bathtubs. This rule applies to both recessed and surface-mounted fixtures. The primary reason for this requirement is safety. The combination of water and electricity presents a significant risk of electrical shock and electrocution. Installing lights directly above or within these areas increases the chance of contact between water and electrical components, which can lead to hazardous situations. Ground fault circuit interrupters, or GFCIs, play a crucial role in protecting against electrical shocks in areas with water exposure, such as bathrooms. GFCIs are designed to detect even small imbalances in electrical current. If a fault is detected, the GFCI will quickly trip the circuit, cutting off the power and preventing a potentially dangerous shock. Combo devices, which integrate a GFCI with a switch in a single unit, are often used in bathrooms to provide GFCI protection for lighting fixtures and other electrical outlets. It is important to note the difference between the NEC and the HUD code. The HUD code refers to the building standards specifically for manufactured homes, including mobile homes. These standards are enforced by the U.S. Department of Housing and Urban Development, or HUD. While the HUD code itself doesn't have specific requirements for lighting fixtures in showers, it does mandate that all electrical installations within manufactured homes must comply with the NEC. This means that even under HUD code, the NEC restrictions on installing lighting fixtures directly above or within showers and bathtubs must be followed. To summarize, the NEC prohibits the installation of lighting fixtures directly above or within showers or bathtubs. While the HUD code doesn't explicitly address shower lighting, it requires all electrical installations to adhere to the NEC. Therefore, installing low-voltage lights in showers, even with GFCI protection, is generally not permitted according to these codes. For written proof of these regulations, refer to NEC Section 410.10 C, which states lighting fixtures shall not be installed directly above or within showers or bathtubs. Also, consult HUD Section 3280.204 F, which states all electrical installations shall comply with the NEC. Understanding and adhering to these codes is essential for ensuring electrical safety in residential buildings. It's important to prioritize safety and consult the most recent version of the NEC and any applicable local codes for the most accurate and up-to-date information. In the context of electrical installations, several factors contribute to ensuring safety and compliance with the National Electrical Code, or NEC. These factors include proper wiring methods, appropriate overcurrent protection, grounding and bonding techniques, and adherence to specific equipment listing and labeling requirements. Firstly, wiring methods are crucial for ensuring the safe and reliable distribution of electricity. The NEC outlines various wiring methods, each with its own set of requirements and limitations. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable, often referred to as ROMEX. Each wiring method is suitable for specific applications and environments. For instance, rigid metal conduit provides excellent physical protection and is often used in areas where wiring is exposed to potential damage. Non-metallic sheathed cable is commonly used in residential wiring for its ease of installation. The NEC specifies the allowable uses and restrictions for each wiring method, including requirements for supporting and securing cables, protecting cables from physical damage, and ensuring proper spacing and clearance. Secondly, overcurrent protection is essential for preventing damage to electrical equipment and reducing the risk of fire. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds a safe level. Circuit breakers are resettable devices that trip automatically when an overcurrent condition occurs, while fuses are one-time devices that must be replaced after they blow. The NEC mandates the use of overcurrent protection devices in all electrical circuits and equipment. The size and type of overcurrent protection device must be carefully selected based on the ampacity of the conductors and the rating of the equipment being protected. Improperly sized overcurrent protection devices can lead to overheating of conductors, insulation damage, and potential fire hazards. Thirdly, grounding and bonding are critical for providing a safe path for fault current to return to the source, minimizing the risk of electrical shock. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of metallic parts of the electrical system to create an electrically conductive path. The NEC requires that all electrical equipment be properly grounded and bonded to ensure that fault currents can be safely cleared. Grounding electrodes, such as ground rods, ground plates, and metal water pipes, are used to establish a connection to the earth. Bonding conductors, such as equipment grounding conductors and bonding jumpers, are used to connect metallic parts of the electrical system. Proper grounding and bonding practices help to reduce the voltage potential between different parts of the electrical system, minimizing the risk of electrical shock. Fourthly, equipment listing and labeling are important for ensuring that electrical equipment has been tested and certified to meet safety standards. Listing and labeling organizations such as Underwriters Laboratories, ORAL, and Intertek conduct testing and evaluation of electrical equipment to verify that it complies with applicable safety standards. Listed and labeled equipment bears a mark indicating that it has been tested and certified. The NEC requires that all electrical equipment be listed and labeled for its intended use. This requirement helps to ensure that equipment has been designed and manufactured to meet minimum safety standards. When selecting electrical equipment, it is important to look for the listing mark of a recognized testing laboratory. Furthermore, the NEC contains numerous specific requirements for different types of electrical equipment and installations. These requirements cover a wide range of topics, including wiring methods, overcurrent protection, grounding and bonding, equipment listing and labeling, and specific requirements for certain types of occupancies. Compliance with these requirements is essential for ensuring the safety and reliability of electrical installations. Electrical inspectors play a critical role in enforcing the NEC and ensuring that electrical installations comply with applicable codes and standards. Electrical inspectors review plans, conduct inspections, and issue permits to verify that electrical work is performed safely and in accordance with the NEC. When planning and executing electrical work, it is important to consult with a qualified electrician and obtain the necessary permits and inspections. Working with a qualified electrician helps to ensure that the work is performed safely and in compliance with all applicable codes and standards. Obtaining permits and inspections provides an additional level of oversight and helps to verify that the work meets minimum safety requirements. In addition to the NEC, many local jurisdictions have adopted their own electrical codes and standards. These local codes may contain additional requirements or modifications to the NEC. It is important to be familiar with the local electrical codes in your area and to ensure that electrical work complies with all applicable requirements. Failure to comply with electrical codes can result in fines, penalties, and potential safety hazards. Staying up to date on the latest changes to the NEC and local electrical codes is essential for ensuring that electrical installations are safe and compliant. The NEC is updated every 3 years, and it is important to review the latest edition to stay informed of any changes or revisions. Attending continuing education courses and seminars can also help to stay abreast of the latest developments in the electrical industry. By adhering to proper wiring methods, providing appropriate overcurrent protection, implementing effective grounding and bonding techniques, and ensuring compliance with equipment listing and labeling requirements, electrical installations can be made safer and more reliable. Consulting with qualified electricians, obtaining necessary permits and inspections, and staying up to date on the latest changes to the NEC and local electrical codes are all important steps in ensuring electrical safety and compliance. The NEC is a comprehensive set of standards that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding and bonding, equipment listing and labeling, and specific requirements for certain types of occupancies. Understanding and complying with the NEC is essential for ensuring the safety and reliability of electrical installations. Electrical safety is paramount, and adherence to the NEC and other applicable codes and standards is critical for protecting people and property from electrical hazards. Taking the time to learn about electrical safety and to follow proper installation practices can help to prevent accidents and injuries. The NEC is a living document that is constantly evolving to reflect new technologies and best practices. It is important to stay informed of the latest changes to the NEC and to adapt your electrical work accordingly. By staying current with the NEC and other relevant codes and standards, you can help to ensure that your electrical work is safe, compliant, and reliable. The NEC serves as the cornerstone of electrical safety in the United States and beyond. Its comprehensive provisions and ongoing updates reflect a commitment to protecting individuals and property from the inherent hazards associated with electricity. Understanding and adhering to the NEC is not merely a matter of compliance, but a fundamental responsibility for anyone involved in electrical work. By embracing the principles of the NEC and continually expanding one's knowledge of electrical safety, individuals can contribute to a safer and more reliable electrical environment for all.